We start with example on 7.1. A traffic light weighing 22 pounds is suspended by two wires, and we have a picture of how that's done. We call this point B, we call this point C, and we have the two wires, and we have a traffic light that is suspended by those two wires. We need to find the magnitude of the tension in the two wires. So we have the first tension, we're going to call this T1, and then we have the other tension, which we're going to call T2. I'm going to label this as 22 pounds. So what I have is I have three weights: tension 1, tension 2, and my tension 3, which is actually known. Now this is the physics of it. Before I go into physics, I need to know the degrees. Now the 60 degrees and the 45 degrees is part of the problem. I do know that these are perpendicular because the traffic light is not going anywhere, it's stationary. I know that the forces need to add up to 0. What we have in geometry, so the geometric point of view of this object, is we will form a triangle that is basically going in circles. Now the way these tensions will work, and we'll talk about vectors next time, but that's what I'm actually using right here, is that these T1, T2, and 22 pounds can be moved around basically to form a triangle. So what I'm doing is I keep this 22 right here. I don't need this. Let me erase that. So I need the 22. It's a force that's going this way. I need T1. So I'll basically take this, pick this up, and move this over here. So this is my T1. That force is going that way. And I have my T2. So I basically pick this up and I go and I label it right here. That force is going this way. So what I have is I have physics of the tension is stable. Now I need some degrees that I have to put here. So I know that if I draw this perpendicular, this T1 forms 60 degrees. Now this is the same 60 degrees as I have over here. This is the same 60 degrees. As far as T2 is concerned, if I know that this is a perpendicular, I know this is 45 degrees. This 45 is the same as this 45. The light is hanging straight down, so I do know it's perpendicular. Now it has to match. So if this is 60 degrees, this is 45 degrees, I do form alternate interior angles. So this is your geometry class. These do form this. These are equal to each other, so they form 45 degrees. Now if you add up 60 plus 45, you'll get 105. Minus that from 180, you know that this particular angle is 75 degrees. I also know that these are another pair of alternate interior angles, so this again forms a 60 degrees. So once I have my triangles, my angles, I have a side that's opposite of the 75 degrees, I can easily start my law of sines. So sine of 75 degrees divided by 22 is equal to, and then pick an angle, any angle, sine of 60 divided by its opposite, so I have the T2. My T2 is equal to 22 times sine of 60 degrees divided by sine of 75 degrees. If you plot this in the calculator, you'll get your T2 to be approximately 19.7 pounds. I'm going to be doing similarly sine of 75 degrees divided by 22, but now I'm going to use the other angle. So I'll have sine of 45 degrees divided by the side that's opposite of that one, which is my T1. So with proportion, my T1 is equal to 22 sine of 45 degrees divided by sine of 75 degrees. Again, if you plot this in the calculator, your T1 comes out to 16.1 pounds. Now this should make sense, that if you have, so your T1 is 16.1, your T2 is 19.7. So if you have a 22-pound weight, it's somehow distributed a little bit on this side, distributed a little bit on this side, but they have to add up to something that's bigger than 22 because we're pushing it aside as well. So this is it for this particular example.